Okay, moving into lesson 2, we're going to look at rational equations and how to use what we just talked about in lesson 1 to solve those. And so the biggest thing that you need to get out of this lesson is making sure you understand the difference between adding and subtracting and solving rational equations. So equations, expressions, one will have an equal sign, one will not. We will not approach them the exact same way. However, we will use like our LCD and stuff like that to get us there. So if you're following along in the textbook, this would be like section 6.3. This is section 6.6. And you can kind of look at those differences there. Also, if you look at page 437, number 91, make sure you understand the response that's given in the back of the book as far as those differences. You can find the textbook underneath our class resources page. And it's just an online textbook if you didn't pick one up or check one out. So just a quick review of how to add fractions. You need to know the LCD so that you can get a common denominator. You would multiply all your fractions to get that common denominator and then add over the top. All right, so moving into this first example, if we want to solve instead of just add, so here we're adding these two things together. So we're adding 4x plus 4 over x plus 3 over 4, which is different from solving 4 over x plus 3 over 4 is equal to 1/2. All right, so that is different. If you're solving that, first you're going to find your domain restrictions of the original problem, because if we solve for x and it happens to be a domain restriction originally, then there is not going to be a solution, or that one solution is what we call extraneous. X is equal to, cannot equal 0 here because 4 over 0 is undefined. So x cannot equal 0. The LCD will be 4 and x because 4x is divisible for x and 2. Okay, and so that is our LCD. It's a list of every different fraction or something that, or denominator, or something that the denominators will go into. So all of our denominators go into that. So then we're going to multiply both sides by that LCD, by that common denominator, to eliminate the fractions. This we talked about in Unit 1, clearing our fractions. All right, so 4x over 1 goes through to each of these things. So we get 4x times 4 over x, 4x times 3 over 4, and 4x times 2. The reason we do that is now we can go through and those cancel there, those cancel there. That reduces there. Okay, and so we end up with 16 plus 3x is equal to 2x. This one you can solve by subtracting 16, or you could subtract 3x and then divide by -1. Either way, the result is x equals -16, which is not 0. So it's not our restricted value. And so that solution is just fine. All right, as long as you check against the domain restrictions, make sure your answer is not a domain restriction. You don't have to plug it in, but plugging it in is still going to be a great way to double check your results. Okay, so let's move into a more complicated example and walk through it step by step. So you have 3 fractions here. And just like we started with our addition problems, we're going to start these the same way. So that first step is to factor anything I need to factor. So here it's taking out a 2, leaving that x plus 2 inside. That gives me the ability to see if I have any like denominators already and what my complete LCD might be. So here, my LCD is going to be, and I can see here I have a 2, I have an x plus 2, and then I have an x minus 1. So it's a list of each of those different ones. So my LCD is going to be 2, x plus 2, and x minus 1. Now eventually you'll be able to kind of streamline this next step, but you are going to multiply through by that LCD. All right, so you get 5 times 2 times x plus 2 times x minus 1 minus 1 times 2 times x plus 2 times x minus 1. Notice nothing about the denominator has changed yet, and that's equal to 3 times 2 times x plus 2 times x minus 1. All right, so I multiplied this LCD over 1 through my entire fraction. All right, then I can cross out. So this cancels this, and this cancels this. That gives me the 5 that needs to distribute. So I get 5x minus 5. All right, these x minus 1s will cancel. This negative 1 is going to multiply with my negative 2 to give me negative 2. And then that negative 2 is going to distribute. Right? And if you would rather take this extra step and put 5 times x minus 1 and then negative 2 times x plus 2 and then distribute, that's fine. All right, so I get negative 2x minus 4 equals, again, I'm going to cancel these x plus 2's. 3 times 2 is 6, and that 6 distributes through, so 6x minus 6. From there, I'm going to do algebra and solve. So I combine like terms, and I get 3x minus 9 is equal to 6x minus 6. I'm going to subtract 3x and add 6. So that I get negative 3 is equal to 3x. And I can just solve quickly from there. So x equals negative 1. Now, what I did not do at the very beginning was list my restrictions. And you can do that just based off your LCD. So, based off my LCD, x cannot equal negative 2, because that would make this one 0, or positive 1, which would make that one 0. All right, well, it doesn't. It equals negative 1. Once again, I could plug in and double check, but I don't have to. And I don't necessarily need to. But do check against your domain restriction. And this is my solutions set. Okay. So moving forward, I want you to go ahead and pause the video. You don't have to solve it all the way out, but I want you to factor everything and identify your LCD. Okay, so here our LCD is x and x minus 6, so our restrictions would be 0 and 6. Just to kind of do this a little bit differently here, I'm going to just write my LCD above each one. So I'm going to multiply this fraction by x and x minus 6. This one goes by x and x minus 6. And this one goes by x and x minus 6. And so hopefully you'll start getting to where you can go a little bit faster rather than rewrite the whole problem. And so here the x minus 6's will cancel, and I'm left with x times x minus 2. Minus here, the x's cancel, so I have 4 times x minus 6. And then here, the whole denominator cancels, and I'm left with 24. All right, this one, hopefully you're seeing that right here, when I distribute, I'm going to end up with an x squared. That automatically makes this a quadratic problem. So we have to refer once again to last unit. And make sure that we are solving by factoring. So I'm going to do two steps at once here. I'm going to combine like terms, but I'm also going to go ahead and subtract this 24 because this is unit 2 less than 4. I have to get it set to 0. All right, so I have x squared minus 6x. 24 minus 24 is 0. So that one is done. And then I bring out an x. And I could stop right here because I see that that is my LCD, or you could keep going. X equals 0, x equals 6. X cannot be either of those. It can't be 0 and it can't be 6 because both are domain restrictions. At this, I would probably go back and double check all of my work. This happens to be correct. There is no solution to this problem. There's not an x value that works. Okay. All right, so now that we've walked through two of them, I want you to go ahead and try number 3 completely on your own. So factor, identify the LCD, multiply it through, all right, solve the resulting quadratic, and then check against your domain restrictions. Go ahead and check your work against mine. All right, so the LCD is x plus 1 and x plus 4. That's, again, a list of factors from your denominator. So you're going to multiply that through by every fraction listed. All right, so the denominator cancels with 1 on the numerator. And hopefully you're seeing that essentially we're multiplying the top by what the bottom is missing. So it was missing an x plus 1. Now we're giving it an x plus 1. So x times x plus 1, negative 2 times the x plus 4, negative 2 on this side, everything canceled, and that's all we have. Okay, so here's the answer. I got interrupted, so I'm not sure where I left off, but just double check your steps. Multiplied through by the LCD, canceled everything out, distribute through. So now we have a quadratic. As soon as we have a quadratic, all right, as soon as you see that x squared, then you need to refer to Unit 2 Lesson 4 and solve by factoring. You can use quadratic formula if you'd rather, but get that set equal to 0, factor, and solve. Check against the domain restrictions. These all check out, and so we are done. Just real quick, looking at the domain restrictions and the domain. If your domain restrictions are -4, -1, then your domain would be negative infinity to -4, union -4 to 1, union 1 to infinity. So we're just jumping over each of those domain restrictions. Okay, up here, going back, our domain restrictions were -2 and 1. Same thing, negative infinity, -2, 2 to 1, then 1 to infinity. Jumping over those restrictions. All right, so sometimes you'll get lucky and you're not adding or subtracting. You just have one fraction equal to another. You're not adding or subtracting anything like we did in the last two examples. If you have a fraction equal a fraction, this can be solved by the extremes means property. Which just is a fancy way of saying cross multiply or cross products. All right, so what I mean is equal to x plus 2 over x plus 4. We're just going to take if you have a over b is equal to c over d, this is the same as AD is equal to CB. All right, so here we're just going to take this one over here and this one over here. So we have x plus 1 times x minus 4, which is equal to x plus 2 times x minus 5. And you will get the same answer if you still use the same method we were using above and multiplying that way. So this gives us x squared minus, here's 1x minus 4x is minus 3x minus 4. And here is x squared minus 5 plus 2 is minus 3x minus 10. Well, for this one, I have this and this that matches this and this, so they cancel each other out. So I get negative 4 is equal to negative 10, which is no solution because that is a false statement. Domain restrictions still apply here. My domain restriction is x cannot equal 5 or 4. It doesn't really in the end matter because it was no solution, and so it's not either 5 or 4 because it's nothing at all. All right, so continuing with that, go ahead and look at this problem here. We have 6 over a plus 2 is equal to a over a plus 2. Now, you can take a cross product and you can solve this out. Or you can see something, but we'll just try that first. So we get 6 times a plus 2 is equal to a times a plus 2. So 6a plus 2 is equal to a squared plus 2a. I'm going to get this equal to 0, so a squared minus 4a minus 2, and then factor and solve. So oops, this is 12, sorry, minus 12. A minus 6 and a plus 2. So a equals 6 or negative 2. Well, negative 2 is a domain restriction. It cannot be negative 2. Your domain goes from negative infinity to negative 2, and then from negative 2 to infinity. It skips right over that value. So this is a domain restriction. Which means that you can't use it. So the only solution is 6. Now, jumping all the way back up here, you could have avoided all that work by saying, okay, well, if I have two fractions that have equal denominators, then the numerators also must be equal. All right, so right away, a is equal to 6. All right, I would go ahead and solve it out just in case the second answer isn't a restriction, but just be aware that that automatically gives you one of your answers. Okay. So ratio leads to our word problems here. Remember that a ratio is when we compare two numbers to two others. So the ratio of pickup trucks to cars sold at a dealership is 2 to 3. And so that is our ratio, is 2 to 3. And so if we let's switch colors here. Let x equal the number of pickup trucks because this goes on to say if the dealership sold 142 more cars than pickup trucks, so the relationship has to do with pickup trucks, then how many of each did it sell? And so when we set this up, know that we have our ratio, and I would just write it out. Our ratio is pickups to cars. Pickups to cars. All right, well, that is 2 to 3. And that ratio is where X is the number of pickup trucks and cars is the number of pickup trucks plus 142. Okay, so this gives you your ratio that you can then solve. So we're going to multiply here and we get 3x. And that's equal to, and then we're going to multiply here. And that's 2 times x plus 142. And then we can just solve algebraically. So 3x equals 2x plus 284. So x equals 284. All right, so the dealership sold, answering the question, 284 pickups and adding 142 to that, 426 cars. Make sure you answer the question. Okay, and that's it. Have a good night.